Hi Benjamin, how are you?
Hi, Mr. Show. I'm doing good.
Okay,
How about you?
we'll get started, okay?
Yeah, okay.
How are you?
I'm doing good. How about
Okay,
you?
I'm okay. Actually, another person, Jessica, is on orientation, okay?
Oh,
She went to UCLA for the orientation. They get started already.
okay.
Okay, anyway, let's get started. Today we will be continuing our pointer and array discussion, okay?
Yeah.
We started last week. So last week we talked about a pointer and the array. An array is continuous memory of some data type. Okay, we talked about it before. Pointer is the address storage. It
Yeah.
stores some address. So usually you store the address of the array and then put it here. And the pointer can be calculated. You can increase, you can decrease, you can move around the pointer, up down the pointer to the array. Okay, that's what we learned last time.
Yeah.
So that's the basic idea of the pointer and address. So you can assign the address of an array to the pointer. That's what we said before. We also say that pointer can be used when you pass the reference variable to the memory. We also go into the level 1, level 2 pointer last time. Okay. So double pointer, we talked about it before. So these are the basic pointer, pointer 1, pointer 2, we already go into there. And then next one is the pointer and functional argument. So you do have the A, B, this one is call by reference. So you only pass the value 3, 4 into there and they swap. And they really swap the A, B. And you can also pass the address of the memory A with 3 and memory B with 4. So this pointer pointed to here, this pointer pointed to here. When you do swap, they are swapping the body of the pointer. Body of pointer is these two variable. It got swapped over here. So really, this one is passed by reference. Address is one kind of reference. Okay, this is passed by value. When you don't want to change the variable, this is input only variable. This is input output variable. Okay, when we have that, we talked about it before. Okay, that's actually okay. And then next one, we are going to talk about pointer and array. So you have a for, this one is your I location. When we declare integer p star, this means that the body of P is a pointer. Body of P is a storage. Body of P is a integer. That's what this one say. Okay. So when you say body of P is a it's an integer, this means the P is a pointer. So P can store some address of A. That's what we said before. Okay, that's what it is. I think this one okay so far.
Yeah.
And pointer, when you don't store value to there, you can store a null or a zero there. You can also store null PTR. This is a null pointer. Okay, this one in C double plus, they usually use a null pointer instead of null. It's the same. It actually, they all are zeros. Okay, but C double plus tend to store null PTR. That's a null pointer. Okay, in shorter length. So when you're not pointing to any set. Okay, next one we are going to talk about the array and the address calculation. Okay, so now let's look at the array design issues and its address calculation. Okay, let's look at this one. So let's actually look at this one. Let's actually look at address one. Let's see. Okay. Okay, anyway, here you can declare an integer A array of 3 elements, okay? So this one is different from Java, okay? In Java, let's actually look at Java. Java, you declare integer array A equals new integer of 3. Or you declare A array equals new integer of 3, okay? So this actually your memory is in heap. Okay, your memory is actually in heap. Okay, it's actually in heap. Okay, let's just delete it. It's look like it's not a command. Let's actually delete it. Okay, let's be sure this one is a command. So this one is in heap. This one also in heap. That means that they are dynamic memory, and they allocate the memory of 3 elements in heap. And then they assign the memory address to the variable reference variable A right here. This one is different. This one in C language. This one is not in heap. This one is in. This one is in data section, or sometimes we call it constant pool. So it's actually some sort of static array. It has its memory location fixed for you. Okay, when you declare this, but when you declare this, there's no content. So this one is no initialization. Maybe garbage. Okay, in Java, you automatically clean it as a 0, but right here, it may have garbage, but it's okay. Let's do this. Okay. So let's actually do integer a length equals, okay, there's a function called size of, so size of A divided by size of integer. Okay. So size of A, let's actually look at size of A and size of integer. That's before we do anything else. So size of A means that how many elements in the A array, okay? Let's look at it. So there's a function you can use for size of, okay. Okay, let's go up to here, okay? Before we go in any further, let's look at the size of first. So size of A, you have 3 elements, and then it's actually give you 12. That means size of A, they look at this A3. They are totally 12 bytes in use, but they are only 3 integer because each integer is 4 bytes. So the length of the array really is not size of A. Size of A is the number of bytes allocated for the array, right? Size of integer is each integer has how many bits. So the length of the array, so let's do integer A length would be equal size of A divided by size of integer. So that's the right size of the array, okay? So let's actually copy this. Let's talk about this one is called A array. Okay. So the size of A array is eta length. Okay, this A length is really is eta length. So eta length actually is really size of A divided by integer. Okay. Okay, it is 3. Why I'm talking about this because I see your homework right here. You use A0. It is okay, but sometimes A maybe is empty. So your A0 sometimes you don't have elements. So use A0 right here is risky. Is that okay? Is that okay?
Yeah.
So it's better that you actually have the size of A, and then if it is character, you use a size of char. If it's integer, you use a size of integer.
Yeah.
Okay, that's eta length, how to see the A length. Okay, A length. So here we talk about calculation of A length. But in C language, there is no eta length, so you have to calculate it by yourself. Okay, so that's number 1, how to calculate the A length. Okay, this one we know about it. Okay, so we know about A length. What is A length? Okay, so this one, let's actually do this. We have one calculation of A length. Okay, what's the power? Let's do green distillation, one empty line. Okay, now next one, what we would like to say is that this one we actually allocate 3 memory to A, but at this moment is all garbages. So we do for integer I equal 0, I less than A length, I increase. And then we do printf. Okay, we print now each element of the I location. At this moment, they are not clean yet. So we got O0, we are lucky. We actually do not initialize it, but we actually got lucky get the O0. But usually, if you never use it before, we recommend you to do one thing. We recommend you to do initialization, so you initialize each element to 0. Okay? Even though that looks like redundant, but in C language, we recommend that to avoid error. Okay? Okay, that's actually initialization. So you can initialize that, but that actually it taking longer time. So you can also do this. There's another way you can do it is integer A, let's do B, let's see. You can do example this, but to directly assign the number to B. So this one is declared and the initialize. But this one, remember, it's actually is creating a reference B. B is the array name. So you allocate 3 elements of it and you put the 10, 20, 30 over there. Okay, you put it over there. So we do change line. Now you also want to calculate the B length. So you calculate the B element. Since the eta length, beta length, you don't have that. So every time C language, you can automatically put this kind of thing in the beginning part. Okay, that would be easier. So let's do copy and paste. Right here, don't do this. Okay, don't do assignment. This one we are going to use blen, and then we do print out the variable. Okay, so this one is you actually initialize the array as well. So you got these, okay. Third one, you can do this. You can do integer C array equals 100, 200, 300. Okay. What is the difference between this one and this one?
The B can only have three different values while there's no limit for C, or Hmm.
In reality, they are the same, okay?
Oh,
But when you interpret it, it is like this. Actually, when you declare this, P is an address to the array of 3 elements. C is the address of to an array of unknown lengths. But which unknown lengths got assigned to it actually is this array's address being assigned to C. This array's address being assigned to B. Is that okay?
yeah.
And this one is you have actually you allocate 3 new array address assigned to A. So in fact, this 3 is the same, except that A assign a array from a constant pool with 0, 0, 0. This one assign a constant pool with 10, 20, 30 assigned to it. C assign 100, 200, 300 to it. B is already saying that it's a address to 3 element array. C, you are saying that it's a array address to unknown lengths, but unknown lengths you already assign a body to it, so unknown really is also known. Okay, unknown really is also known. So this one you can also do C then equals C, and then you actually copy the whole thing to print it again. Okay, so this A, B, C, they are all memory address to array. Okay, they are all memory address to array, and then we can do all similar thing to them, and they all work in the same way. Okay. Now there's a question. Now, can we do this? Can we do integer pointer d will be equal to 1,000, 2,000, 3,000? Is that your d is a pointer to an array, and we assign an array address of 10,000, 2,000, 3,000 today? Is that okay? Can we do this? Can we do integer d then equals size of b divided by size of integer, and then we do the same thing for it for d. Can we do that? No, you cannot. You cannot, because this actually have a type mismatch. You assign the reference of a array to an integer pointer type. So it said that you actually initialization from integer pointer to integer. That's actually wrong. You cannot assign an integer to integer pointer. So this, in a way, this doesn't work. This doesn't work. This doesn't work, but right here we have a d. Okay, so here let's see. Let's do D equals interest of C. D equals C. D is a pointer. Let's actually do this. Let's do integer body of D. D is a pointer. And assign C to that. Let's save and run. Well, it's okay now. Is it okay?
Yeah.
But the size of D divided by the integer actually is wrong. You see, it actually only showing 2 instead of 3. So why is that? Because your D is a pointer pointing to here, but D really doesn't have the length of the array. So this one actually doesn't make any sense. This line doesn't make any sense. So because you assign the address of C right here, you should use the C length instead of D length. D doesn't have the length because D is a pointer. D only calculate the address. D, you use this to calculate it, that's fine. But D, you use that to calculate the C length. The D length actually is wrong. You cannot do that. So the pointer and array is slightly different. They are not really the same. This is okay. You assign the address to it, and then you actually calculate D length. But this one make no sense because D is not an array. D is a pointer. D is a pointer. You calculate the length of the pointer, making no sense. No matter what number you get, it's actually making no sense. But in order to know about use D as a pointer to point into the C array, that actually is fine. D is a pointer, so you assign the C address to D, that's actually is fine. Okay, now let's actually do another thing. Let's do D equals A. Okay, and then redo it again, redo this part again. But this time, because you are on A array, so you should use A length instead of C length. So what I want to say is that D is a pointer, so D can be used like an array, but D really have to use the right length associated with the body, not associated with the pointer. The pointer's length making no sense. The body's length, the array's length making more sense. Is that okay?
Yeah.
So here this is about the calculation of the ages. Now one more. One more is that we can declare something called integer pointer P. Okay, so P again now is an array. It's an array to integer. And then right here, let's do this. Let's do P equals B. You assign the address of array to that. So let's declare integer P length would be equal to P length. Okay, this would be a better way to create it. So PB is the same reference, length is the same. And then let's do this, let's copy this B length, actually let's copy this P length over. So now we use a different way. We do not use we use the B length, but every time we would do P, and then we'll do the body of P. Okay, so every time we use the pointer P's value, and in here we do P increase. Instead of P's I, you use P's I, that will work, but you can also use a P++ to actually, this is different. P's I is P's right here, P pointing to the beginning of the array. So P's I is using 0, 1, 2 to calculate the offset and then get the memory. This is using P's I. P increase means that initially your pointing to P0 location. Then P increase, you move to P1, then you move to P2. So every time you use the body to actually get the access, you get this point, this point. So this kind of P, we call it iterator. Okay, we call it iterator. It's somewhat similar to the scanner SC.next integer in Java, okay, or input that next integer. It will try to get to the next integer because you do P++, you will more like next integer. So right here, that's actually, let's change it, okay. It's not P, it's just called body of P, okay. That's a save, and that's wrong. So body of P, you get 10, 20, 30. Is that okay so far? Since you use the P as a body. Okay. So right here, we talk about A3. A allocate 3 memory right away in the static, the data section. B also allocate 3 memory right away. Okay. A actually initialize to 0. B allocate 2, 20, 30, 30. C also allocate 3 memory, but initially you don't know the size, but because you assign the body to it, so you still know the size. So that's fine, okay? Then next one, we declare a D. D really is a pointer to the address of C, and D doesn't hold the body. That's a pointer. P also is a pointer. It holds the address of B, so it pointing to here. It doesn't hold the body, okay? So the array and the pointer can be mixed to use, but conceptually they are different. Any questions so far?
No.
So P is used to be an iterator. You can increase the number. C is used as an array access. So if you like array access, you use the ABC. If you use the pointer or iterator, you use the body of A, body of B, okay? You use that. So that's the different way to use array. This one is the address calculation, okay? Now let's actually look at number 2. Let's do address 2, let's see. Okay, let's look at address 2, let's see. So we talk about array, that's fine. Okay, let's look at the address 2. No. Oh, no, let's actually look at this one called structure array 3. Okay, now this one you declare structure array 3. Okay, where is the variable name? Which one is the variable name?
Array 3?
No.
Like okay, so in the sentence struct array 3, where's the variable name, right?
Yeah. The whole thing, where is it? Is a variable name?
Oh, and the whole thing. Int A, int B, and C?
No. These are data field name. So right here, this whole structure, no variable name. This thing we call it data type.
Oh.
So right here, why I say that? I say that because right here, let's try do one experiment. So let's do print percentage b backslash n. Okay, so let's try to print. Let's try to print array 3. If it is a variable name, this should be fine, but it is not. It is not. So you run the code, you got a trouble. It's not a variable name. Okay, let's try another thing. Let's try A. Is A a variable name? It's also not a variable name. It's not allowed. How about array 3 that A, since array 3 is a structure and it that A? Still not. Still not. So these are nothing is a variable name. The whole thing is a data type. It's a type of a structure called array 3 with 3 integers, but that's not a data type. That's not a variable name. A variable name is like this. This is a data type. So basically, this is a data type. Let me put it in one line. So this whole thing is a data type, just like integer is a data type. So this data type right here, you should declare a array A1, that's array. So this is a variable name. You can put a variable name right here. Okay, so that's actually do this. We can do integer A1 then equals size of A1 divided by size of integer. So here we print A1 at A. That's the A1 is a variable name. There are 3 data fields, A, B, C. And you print out the A of the A1. That's save, and that's wrong. And it works. Is that okay?
Yeah.
Now let's just think about this. This is a data type. This is a variable name. So this one, let's do this. This is actually data type. Okay, let me put it a little bit closer. So right here, you should have a variable name. Okay, let me put it in this way. Now, may I do it this way? May I initialize it? So this is similar to integer A equals 3. So this is data type. This is a variable name. This is initial data. Make sense?
Yeah.
Okay. Now, if you agree, let's do this. Let's do copy of this. I'm teaching you the concept, okay? I'm teaching you the concept of what is structure and what is pointer to structure and the edges to structure, okay? So
Yeah.
this is fine. Since this is fine, that's actually wrong. So we do print now 1, 2, 3. Okay? So this
Yeah.
one has do 1A, 1 that A equals 1 that B equals 1 that C equals. So what I want to say is that this equals is initial data. You do integer A3. Integer 3 is an array. A is a variable name. and then it equals to 1, 2, 3. 1, 2, 3 is initial data. So right here, if you declare this one, actually A is the variable name. A is not data type. Data type is integer 3-element array. Is that okay?
Yeah.
Right here, when you declare this one called structure 3, A array 3, integer A, B, C, this whole thing is a data type. And variable name is A1. And then initial data is like that. Okay, so you can also do this. After this declaration, you can also do structured array 3 B1 equals 10, 20, 30. Structured array 3 C1 equals 100, 200, 300. So this one, structure 3, you already define as a data type or this type, 3-element type. So this one is a 3-element type, 3-element type is B1, C1. You actually declare that. These are fine, okay. So let's look at this one. Let's actually copy the. Okay, not copy. Let's actually do this. Let's go back. So here, let me copy this whole thing. Let's copy this whole thing. No, let's just print part. Okay. Okay, so A, B, C, we all printed now. And we got all of these. Okay, that's no problem. Okay, so these are actually different. And then we can also do type define array 3. I'm sorry, structure array 3 as array 3. So this one is we define structure array 3 as array 3 type. So array 3 type is the original structure array 3. So you use array 3 to declare variable is also fine. Okay. So now here we can do array 3 E equals 3, 6, 9. That actually is fine. That's actually it's an array 3 type. Okay, that's an array 3 type. Okay, now next one, we are going to do this. Next one, we are going to do integer body of P again. But this time, this body of P, we assign as A1. So this A1 actually is A1 is a structure. You try to assign the structure to this, that's not okay. So you can do A1's address. Because it's integer to a pointer to an integer, so you use A1, that's not okay. You use the address of A1, this is fine, because left-hand side, P is left-hand side. Okay, left-hand side, sometimes I write as left-hand side, okay. P is a pointer to integer. So right hand side need an address to integer. Okay, so A is this is a address to integer. Now you got the A length, you got the A length. So if you do this, if you do a for loop, okay, you do a for loop, and then each time you do this, you do print now the body of P. Body of P. This one should be A1 length. Okay, since P pointing to A1 and you do body of P, so you do PHS increase. So what this one is that you do have a structure. The structure is A1, A, B, C. This variable is called A1. So your P is pointing to here, the A1's AHS. You start to print out the body of this, body of this, body of this. Every time you iterate through it, you increase the iterator. So you got what you want, 0, 1, 2. This one. A1 is 1, 2, 3. A1 is 1, 2, 3. So you assign the ages of A1. You actually print now P is A1's ages. How come you get a 0, 1, 2? I don't get it. Let me see. Here, let me put another one. Let me put a D++ first. What happened? Still 0, 1, 2. Something wrong. Let me do one more time. Sorry. Let me change it. Okay, let me change it. Let me assign P equals ages of B1.A. See what happened. Still 0, 1, 2. Where it is? How comes my P actually got the wrong data? If P is the ages of A1, I'm sorry, this is something wrong, okay? Something wrong. Let me check. So if P is the ages of A1, then the body of the P should be A1. A1 should get the 1. So let me see right here before we print everything. Let's print out the. Let's right here. Let's print out one more time with the A1.1, A1.A. Okay, let's print out the A1.A. A1.A. A1.A should be equal to 1. A1.A is 1. Then how comes the P is, oh, this one's I, I'm sorry. We know I, it's for I, that's wrong. Okay, I'm sorry. So that's because you print out I, okay. Body of P got ignored, so you print out the index, that's wrong. Okay, this is correct. Okay, I'm sorry. So that's actually because I print out the wrong thing. Okay. So this one we got A, B, C. So using pointer need to be very careful. What this one I want to say is you A1 is right here. It has the A, B, C, the pointer of the P using the address of the A1 that A's address. So it pointed to here. And then next time when P++, it moved to here. When P++, it moved to here. Okay, so what I want to say is the structure, you have different structure. Array, you have different index. So your pointer of the is actually only see the body of each type. Your P can point to here, your P can also point to here. It's okay? Now let's do one more experiment. One more experiment is we do have integer D array of 3 will be equal to 369. Okay, let's do this now. Here, the pointer of the P using the address of A1, and then now here we do P will be equal to D. Okay, P equals D to D. And then we actually print out the body of P one more time now. Body is these edges and that. I don't know. It should be fine. There's actually, let's change it to 3. Oh, integer, incompatible assigning integer pointer to array3 type. P is array3 type? No, let's do a different one. Let's do integer barbecue equals. D. Oh, D already here, array3, I'm sorry. So I duplicate it. Let's actually change it to E then. Okay, I make a mistake. So this one is still using P. Okay, still using P. So here should be, because B I already assigned array3 type, so it's wrong. So let's assign E to it. Okay. E is this array of 3 element. D is array3. Okay, it's different. So I use E. Okay.
Yeah.
So what I want to say is array, you declare array of 3 elements. It will be 0, 1, 2, whatever. Okay, this is array of 3 elements. You declare as array3. That is a structure. So you have a B, C, 3 integer field. Okay, but you can use a integer pointer P, the pointer P pointed to here. You can access each one in the array. You can also use the same pointer to the array using the same pointer. But one is this type, one is structure type, one is array type, is pointer type. Either way, as long as it's pointing to an integer pointer P should be okay to do it. So in a way, pointer stores ages, and pointer is also an iterator. Iterator means that you do have input that next integer. Can keep pointing to the next integer pointed, but this input the next integer actually is v plus to increase the pointer, okay? And you can point into the next integer. Any questions so far?
No.
Okay, these are the idea of pointer to. So you can have a pointer to integer, pointer to structure, pointer to array. These are similar things. Let's look at this address 3. This one we talked about it before. But I would like to actually do it one more time. Okay, this one, let's have the main function. Okay, now we do have a function. Let's do a function. This one has a integer function x integer x return x times x. So this one is a square function. Integer t function. Then this one is a cube function. Okay. So we have two functions. And what we want to do next one is to declare a pointer to a function. Pointer to a function. Okay, so pointer to a function is integer. Okay, now let me change my mind. This one I call it f, call it square. This one let's call it cube. Okay. Now the pointer to a function is f is a function. Okay, let's do this. We need a function, f function. This is declaring a f function, but we do need to have a f pointer to a function. So this is body of the f. So body of f, no matter what this one is, let's call it h. H is a function. So body of the f equals h. H is a function. So integer h function equivalent to integer body of f function, because body of f equal h. So this declare f as a pointer to function, because body of f is a function. Body of f is h. H is a function. So body of f is a function. So f is a pointer to function. Is that okay?
Yeah.
Okay, now this is good. So f is a body of the function. So we do this we do f equals square. Okay, and then f suite. Okay. Now if f equals q, Maybe become 27. Is it okay so far?
Yeah.
Okay, next one. Next one, this one is a function. We do assign the pointer, and then we do assign the pointer to the function, and we do call the function using the pointer to call the function. This one is the very basic using address of a function. Now, next one, let's consider this. Let's consider we do have a double, okay, double derivative. Now, I want to pass a function into here, and I would like to take the derivative for it. Okay, so now we want to have a small step size. So double small h equal to 1e minus 9. Okay, what this one is we got a f of x. We would like to dx. It should be limited h approaching 0, h f of x plus h minus f of x, right?
Yeah.
So this is true. This is true. So right now h approaching 0, we use 1 over 10 to the 9 as used for h. Okay, so we would do double dy dx. The differentiate, okay, should be f of x plus h minus f of x divided by h, and then we will do dy dx. Does that make sense?
Yeah.
So right here, let's have a integer x 101 point. Okay, so integer x length should be 101. Okay, let's actually put the opposite way. Let's delete it. Let's do this. Let's do integer x 101. Okay, then actually 101 18. Okay, so for integer I equals 0. I'm sorry. Y, let's do t equals this one is minus 1.0. T less than 1.0. Okay. T equals 2.0 divided by 100. What does this mean? This means that so see, no, here that's actually 2y, okay. This one let's do let's do y. Don't do x, do y. Okay, y please. So this one should be y then minus 1. This one is y then. Okay, so this one, we create a y sequence. This y sequence is starting from minus 1.0 up to 1.0, totally 101 point. So 101 point, each totally 100 step. Each step is 2.0 divided by 100. So it is starting from minus 1 to 1, but there is totally 101 point. Is okay?
Yeah.
So this one here should be less than equal to that. Okay. Then we do y will be equal to df dx dx dt will be your y's I. Okay. So let's get started with I equal 0. I increase. It's okay?
Yeah.
Then we will create, what we will get is, you do get a dfdt as your y, your t starting from minus 1.0 to 1.0. So if f is equal to square, then it should be 2x, because dx squared dx should be 2x. If s cubed, it should be 3s squared. Okay. So before we do that, right here, let's do f equals square. And then let's take derivative. And then let's print out every single point. So let's do print f. Okay. And then do f prime of percentage when do f should be equals LF. Especially here you should use t and y's i's value. So let's do this. Let's don't increase it right here. That actually print it first and then I increase. Okay. Then you will get the derivative value for each point. Now let's do this. It actually doesn't go through. Something wrong. It didn't print anything. It should go through. Let me comment out this part. Let me check it carefully. Okay, making sure it works. Save, then that's gone. Okay, up to here. Okay. Now let's actually go up to here. Okay. Okay, this part. Okay. Now this one we do have this differential one. We actually divide it by that. Okay, that should be fine. And then right here, we started from that minus 1.0 up to 1.0. Every time it will increase by 2.0 divided by y length minus 1. That should be fine. That's the t. So you will pass the f to there. You assign to this. You print f your t and your yi. Your t is a this one integer. So it should be proper. Okay, that's a type L. So there's a double. Okay, let's do it one more time. There's a miss. Type is wrong. Okay. This one. How come is get everything 0 here? Yi. This one is get n. Okay, let's do this. I think this one 0.2 should be fine. This one 0.2 should be fine. This one lets me get more digit. It is wrong. Let's get into here. So we have this for this one. We have passing the x over there. This one is x. We pass the function over there. We do this whole thing divided by h. Let's print now the dydx equals 0.10 LF. Let's do dydx. Let me check if the derivative is calculated correctly. Okay. Oh, this one is in returning integer value. Let's see. It got everything. Let me do it one more time. This is very big value. Dy dx is actually a very big value. Let me see. Okay, I make a mistake because right here is actually is integer. We are expecting it to be a double value. Okay, so let me change it everything to double. So let's do this. Let's do change this one to double. Okay, let's be consistent. Okay, let's be consistent. Let's change everything to double. Okay, change everything to double. So we're going to change it to function to double value. Because integer may be interpreted totally different. So this one is to okay, so this one let me change it to 0.3 LF. Okay. 3 LF. So this is double. So this one it changed to a array of doubles. Okay. Integer length and integer length actually should be fine. Okay, let's try one more time. I think it's correct now. Okay. Is that okay?
Yeah.
It's actually now is actually really is 2x now. Okay, it's 2x now. Let me actually delete the print out of dy dx now. Delete it. Okay, so starting from here. Oh, this is F3. F3, I'm not sure why F3 is wrong. F3, you would return this cube. F3, 0.3F. Let me put in 3.0, okay? Instead of 3. So here, let me put in a bubble. One more time. Okay, so it's correct now. So this one is almost 2, and then it actually up to 108. There is one point it didn't print out. The last point it print out. So right here, after the whole thing, you need to print out one more time. Okay, so here you should have another one that's actually 1.0, and this one is 101. Okay, the last point it missed out. Let's actually print it one more time. Okay, so you would wait 101 actually. Oh, you do not assign value to it. So let's do y 101 equals okay, the last point didn't calculate. So I need to make up one more point for the boundary condition. Okay. Anyway, this one show you the derivative. So let me use a point board to make it shorter. Okay, so the numbers should be prettier because you round off it. Is that okay?
Yeah.
So this one you do get the derivative for a square. So now let's actually do the whole thing over again. Now let me actually put this one as cube. Okay, it's cube. So this one, okay, this we don't need to declare this. This we delete it. It already been there. So I equal 0. Start to redo it for the derivative one more time, but the function changed to cube. Okay. Now that's actually saving and run. This time, let's define item C. Oh, this one equals C. Add the declaration, just reset it. So let's see this time. Let me move to the bottom. So this time is 3x squared. So you got 3 now, okay? It's a cube. So right here, your -1 is also 3x squared. The first part is 2x. So this is dx squared dx. You got this. This is dx cubed dx. You got this. Okay? Anyway, what we want to show you is declare two functions and then pass the two function to a function as a parameter, and we calculate the derivative for it. That's what we do. Okay. Integral, you can do similar way to find the integral for it. Okay, you can find an integral for it. So integral, you will have the f delta x. Okay, limited the delta x approaching 0, right? You will get this one, and this one is called delta y. Okay, it's f h plus x minus f of x. This is delta y. You get delta y equals this. Is that okay?
Yeah.
You will get the integral. So you have a c value, and you have start with f naught, and f1 plus f c from plus delta f. You get this one. You should get your initial point is this one. Okay. Let's assume that your f naught equals c. Then your f1 equals f naught plus delta y. f2 equals f1 plus delta y. You keep doing that, you will get all the integral points. Okay. Anyway, this one just to show you how to pass pointer to functions. Okay. And pointer is address to array, address to structure, and address to function. That's what we try to say today. Okay, so we do that, and then next one, we would like to look at the design issue for array. Regular array, you know it in the Java language, so we don't repeat it anymore. So here we emphasize on the use of the address. Okay, you assign the first element's address to pointer, then you can use the pointer plus some number to find the body for it. It's the same as you use the index format. Okay, that's what we say already. So the part we don't repeat. And you can initialize the value we talked about it already. Okay, address calculation we talked about it already. Every time you advance by the number of type of the data type. Okay, this one talk about it already. Okay, we don't actually waste time on this different one. This one, what I want to say is, okay, level 2, we already talked about it. This one, what I want to say is, let's don't do the n dimension yet. Okay, let's do it later. What I want to say right now is dynamic allocated memory. Okay, another type of memory. So this one is different from this so far. So far, we are using the static memory. You declare an array right from a static array. Okay, now we are going to do another one. Let's call it dynamic one. Let's see. Okay, dynamic memory. We say that the way you declare array is different from what? Different from it's different from the Java. So let's do Java. So in Java, you actually declare an array using integer. array A equals new integer 3. Okay, that's the way you declare a integer array. And we say that this array is in heap. Okay. And it is not static array. Now, how can we declare available in heap? Okay, for dynamic memory. So integer main void. Okay. If we don't want to do static array, how can we declare array in this? Okay, so first one, you still need to have integer a, like the number of elements that you call it 3. Then you should have a integer body of p to be equal to integer pointer memory allocate. Okay, now because you want to use memory, okay, you need to include standard library types. Okay, you need that. So memory allocate, what should you put over here? You need to do ln times size of integer. So this one you declare 3 integer size memory in the heap. And then the address of this one being assigned to P. So P is a pointer to there. But we already said that P can be used as like a array address. So this is similar to, this is the same as just like you do this, just like you do integer P array equals new integer 3. It's the same as that. But at the end, you need to do 3 of the P to put it back to the garbage. Okay, so this one is to recycle the memory. Other than that, it's actually, these two are the same. This is similar to Java's new integer. It will allocate the memory in the heap instead of in the static memory. And then you can use it just like normally you use for array. So integer I equals 0, I less than a, then I increase. Because right here you do not assign value to it. So let's do it. Let's do P of I equals I times I squared. Okay. So you assign a value to P of I and then you print. This is the use of dynamic memory. Oh, we are wrong. I times I is become -4. Oh, we missing I. I'm sorry. We do not print I. Okay, that's an error. Let's do it one more time. So it's 0, 1, 4. Any questions so far?
No.
Okay, so this one you create a memory in heap. So this one and the previous one you use integer A3 equals 1, 2, 3. What happened is, as an array is the same, but for the memory, they store in different locations. One in heap, one is dynamic memory, means that runtime you allocate certain memory for it. This 1, 2, 3 is in A is actually static, when the program gets started, you already allocate that memory for it. So one is direct memory, one is static memory. Two are different. Okay, two are different. Otherwise, the way you use array, using pointer as array is the same as you use the A array address, is the same. But remember to declare a memory variable for the length. Okay? That's the only thing you need to take care of. Now, if you want to allocate a object, so this one is array, right? This one is array. Let's do an object. So object, let's do structure point type. Okay, let's do integer y. So we say this is a type. So we do pointer1, pointer2. Okay. So declare two variable pointer1 and pointer2. Now let's do it right here. Let's do it right here. So these two are pointer1, pointer2. No, let's don't do it this way. Let's have this type. So let's do type define. Structure type point. That's point type. Okay, so point type now is representing structure point. Okay, now we actually would like to see here, we would like to see size of pointer type divided by size of integer. This one we would do integer p length, the size of a pointer. Is okay?
Yeah.
Now we got that, then we would actually do integer. I'm sorry, this one should be not integer now. It should be a pointer. Okay, body of Q is a pointer. So this one is pointer, body of memory allocated. Okay, so it's a p length and size of integer. Okay, we remember that this much memory for a pointer to a point Q. Okay, then we actually would do use x equals 10, use y equals 20. Okay, this is a point. So we will print at and after we finish that, we will still free our queue. Remember, you allocate the memory, then you need to dispense them. In the middle, you use it, okay? So this is creating a dynamic object, dynamic structure. Just like so this one is similar to pointer Q equals new pointer 1020 in Java, okay? So in Java, actually, we do not have the structure available You always a dynamic memory, and dynamic memory is allocated in this way. Okay. Java's array is also dynamic, so it's actually using this memory allocate. But you say new. When you say new, it means the memory allocate. Okay. And then previously we actually look at the structure. We look at the array. These are different. This one are static memory. Okay. Right here we're talking about dynamic memory. Okay. 1020 completed. Any questions so far?
No.
So this is dynamic memory. So today we talk about array. We talk about structure. Okay, X, A, B, C. Okay. We talk about dynamic memory using new. Okay. And memory allocate. Memory allocate for it. Okay. These are some what we learned today. Next one. Let's go back to n-dimension array. Okay, let's go back to n-dimension before we go finish. So n-dimension array is similar to the so-called what's that? Two dimensional array in Java, but it's slightly different. Okay, it's slightly different. Let's look at how it slightly different. So let's do it metric. Okay, let's call it metric. It's slightly different from the concept of the Java language. Okay, now let's do this. Let's do integer a. Let's do n 3 by 3. Okay, so this one is what. Let's do it in the way you actually know it well. Okay, let's do it in a way that you already know it well. So you actually know the two-dimensional array, how you declare it in it's an array of arrays, so actually it's the same. But conceptually, it's different. Okay, conceptually, it's quite different in Java and C++ array, that two-dimensional array. Okay. Okay, so here, if you are in the Java basically you have M33. This one actually is you declare a array of array. So M array, you really have 3 elements. 0, 1, 2. 0 is another array of 3 elements. 2 is another array of 3 elements. 2 is also array of 3 elements. And these 3 actually, each M1 or M2 or M0 is a pointer or is a reference or pointer by themselves. It's an array of array. This is Java. This C is different. C allocate a memory of 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2. So they totally allocate 9 elements of memory for you in a consecutive way. So this is different from what Java would be. So you can do this for integer I equal 0. You don't do I and J, you do this. You do I less than 3 times 3. And then you do in F. your two-dimension, but you use a single index to run it. Is that okay? Yes, it's okay. I'm missing an item put in there. You have different, you do not initiate data for it. Let me see. M33, M33, M33. You assign 1, 2, 3, 4, 5, 6, 7, 8, 9 to it. Yeah, that's correct. Actually, that's correct. Why it actually get a different value? Your I equals 0. I less than 3 times 3, you get this. Let me try, okay? Let me try different thing. Let's actually get this. Okay, let's actually use this, okay? Let's actually do this. Let's put the I and J and Mij into there. Just do it in the regular way for metric, okay? Okay, got to the right one. Let's do it in different way. Let's do it in different. Let's do integer pointer p equals n. And let's do this one more time. Let's actually do for integer I equals 0. I less than 3 times 3. I increase 3. F E percentage E equals percentage E expression. This one is use I and P. I is very. So in a way, I use a one-dimensional array pointer to point into a two-dimensional array. It is not okay. It actually is not okay. So let's try to use the address of n 0, 0. Okay, I'm sorry, using this one. Okay. One more time. Wrong. And it work now, okay?
Yeah.
So what did I want to say? What I want to say is that you really declare a 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can use a p pointer. P pointer is a pointer to integer. It pointed to here. But if you traverse one by one, you will go through this different memory location in one-dimensional array format. So what we want to say is that this two-dimensional array is a two-dimensional array. If you use the M way to look at it, okay, if you look at M ways to look at it, if you look at the P ways to look at it, it really is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a one-dimensional array. So it is a two-dimensional array if you use a M to look at it. It is a one-dimensional array if you look at the P array to look at it. So P can be used using address calculation scheme to go over the whole two-dimensional array one by one using this way. So this is 3 by 3, we can use a different one. Let's use the integer p length will be equal to size of n divided by size of integer. And let's don't use a 3 by 3, let's use p length instead. You still get the same thing. So this is size of n is like the whole n being allocated with 3 by 3 memory. And you kind of divide it by the size of each integer. You should be getting the total number of the integer count. Total number of how many integers are there, we call it p length. Is that okay?
Yeah.
As long as your p pointing to the starting address, no matter it's a structure, it's an array, or it is a two-dimensional array, it's just the same. So structure, two-dimensional array, and the point an array, it actually is the same thing. It's the same thing of the integer structure of different organization. You can look at it as two-dimensional array. You can also look at it as a one-dimensional array, or you can look at it as the structure is the same. Just different kind of organization. Is that okay?
Yeah.
And it's put into the so-called what's that? The so-called is put into the so-called dynamic memory, static memory. Okay. Now, if we want to allocate this one in dynamic memory, let's try it. Okay, let's try to do it in dynamic memory. So basically, you would do a integer pointer. Okay. And then you do memory allocate. You do p then size of integer is 3 by 3, right? Because p then is 3 by 3, so you would allocate that many to the integer pointer. Now you would have integer going to q would be equal to this. Okay. So now this q is one-dimensional integer. So if you do this, no, let's do this. This one is you actually have one-dimensional array of that many elements. Okay. And then you can create a integer n. Okay, let's create an integer n. Let me see. You have a two-dimensional array. You want to. Let's do this. Okay, let's do for integer I equal to times then is. Let's do for integer j equal to j. Let's say j is clean. So q I j. Q is one-dimensional. So this one actually you cannot. Okay, it doesn't allow. But if you do this, if you do I times 3 plus j, that would be using one-dimensional array as a two-dimensional array. Okay, that's our way of printing two-dimensional array. Memory allocate. Oh, I'm missing. Include HTTP library package. Okay, we got some value, but we do not initialize the queue, so those are garbage in the dynamic memory. Okay, but this is using a dynamic allocate memory for two-dimensional array in C language. Okay, any question?
No.
Okay. I see we are up to here for today. Okay, so today we basically introduce array structure and also dynamic memory and the two-dimensional array, three-dimensional array, and then we also using the technique to use a pointer to point it to that. Okay, that's the purpose of this whole thing in chapter 8, the so-called pointer and array. Okay, we give you the introduction. So we finish this chapter. Next week, we will look into more advanced topic, and then we will wrap up the C language. We are ready to move on to C++. Okay? Okay. Good night then. Bye-bye.
All right. Goodbye. Bye, Mr. Zhou.
Bye-bye.